Hello everyone. In this video, we are going to discuss about what is a perceptron or an artificial neuron, what are the basic building blocks of perceptron, how artificial neuron works, why bias is used in perceptron and artificial neural networks. So let's begin. Now, what is a perceptron or an artificial neuron? In my last video, I mentioned that linear and non-linear functions are the basis of deep learning. In this video, you will exactly understand why. So here you can see that a perceptron or an artificial neuron is composed of a weighted sum and an activation function. I recommend you to check my video on how to start with deep learning and deep neural networks before starting this. So here you can see that we have the two inputs, input 0 and input 1. Each input will be associated with a weight. This block will then calculate the weighted sum of inputs and weight, and then it will add bias into it. The output of weighted sum is then further fed into an activation function, and that will give an output. So here the input or the inputs are the input data set that could be a numeric value like price of the house or stock price, etc. Weight or weights will be initialized as any random number close to 0. It could be both positive and negative number. Bias or biases is just added to the multiplied sum of inputs and weights, and further activation function gives the output based on which activation function is used. As we mentioned in our last video, that the equation of line is y is equal to mx plus c, and we had seen that how a line is drawn to classify different classes. Similar to that, the equation of a perceptron is y is equal to wx plus b, where y is the output, w is the weights associated, x is the input, and b is the bias. So if we have the two inputs, let's say 5 and 2, and we have the weights as 0.5 and minus 0.8, so using this equation, output is equal to input 0 into weight 0 plus input 1 into weight 1 plus bias. We will get 5.5 minus 2.8 plus 1, which is equivalent to 3.7. Now we have applied a linear activation function. A linear activation function means the resultant will be 0 if x or the output is less than 0 and 1 if it is greater than equal to 0. So since 3.7 is greater than equal to 0, that means our result will be 1. Now this whole thing, which includes the weighted sum as well as the activation function, is called an artificial neuron or a perceptron. Take another example, let's say we have the n number of features. So we have the n number of weights as well. So each feature or each input is associated with a weight. So we have the n number of weights, and here we get the weighted sum, and then we apply a bias on it. This weighted sum, when passed to a activation function, we get the output. So this predicted output could be what we are expecting, or it could be far away from what we are expecting. So the difference between predicted output and the expected output is the error. Now this difference is passed to the network via backpropagation. Since the inputs are constant, so either we will have to change the weights or we will have to change the bias. And since weights have the direct impact on the predicted output, that's why using backpropagation, weights will get updated. This process will keep on going on until the predicted output is equivalent to the expected output. Till now we have understood how weights and biases are updated to match the expected output. But why bias is required? Consider a scenario when any of the original inputs are 0, because there are possibilities when any of the input is 0. In such a case, even if we keep on varying the weights, the final output still remains 0, and this makes the perceptron redundant in the neural network. For example, as per our equation, if y is equal to wx and there is no b or bias in this case, y always remains 0 when x is equal to 0. Further, the actual input of 0 is not considered by neural network to produce the output, because the input of 0 is actually not contributing in the neural network. Therefore, a bias with an initial value of 1 is added to each neuron so that the output will be non-zero. That's all for this video. Do subscribe to my channel, like the video, and press the bell button to get notification on future videos. Thanks for watching this video. Bye bye.